This is section 7.4. We're going to look at special right triangles. Here's some standardized test practice. Triangle WXY, that's this triangle here, is a right triangle. Find the length of segment WX. So this is a right triangle. Another thing you know is this acute angle is 45 degrees. So that means that your other angle is also 45 degrees. This is a right isosceles triangle. So if two of the angles are the same, two of the sides are the same. That's 25. That's 25. So now you have a right triangle where you know two of the legs. Let's calculate the hypotenuse. That's the distance from W to X squared. 25 squared is 625. $625 plus 625 gives you $1250. So the square root of that is how long this is. So if you type this into your calculator, it'll give you one of these answers. What is the square root of 1250? Gives me 35.36. So clearly that's not 50. Cross that off. Is it 25 times the square root of 2? I'm going to type it in my calculator. What is 25 square root of 2? It is. It's the same number. It can't be 25. If your legs are 25, your hypotenuse has to be longer. 25 square root of 2 is this number. Divided by 2 gives me 17.68. So it's not that one. Anytime you're doing multiple choice, if you find your answer early on, it's always good to check the other options if you have time to make sure that you didn't mess up. This is something really important. When you have an isosceles right triangle, if you know the legs, the hypotenuse, notice, is just that same number that the leg is times the square root of 2. Here's something else that you need to observe. When you have a 45, 45, 90 triangle like this, that's also a right isosceles triangle, it can be formed by cutting a square in half. So here's a square. If you put this diagonal through on a square, it makes two 45, 45, 90 triangles, right isosceles triangles. So here's a right triangle. Notice how the legs are both the same length. How long is the hypotenuse? Well, you can figure it out. We know the Pythagorean theorem, x squared plus x squared equals whatever that unknown is squared. Okay, well, right here you have two x squareds, and that equals whatever your unknown is squared. You want to get the unknown by itself, so you're going to take the square root of this. And that might seem complicated, but you can split it up like this. Remember, you can use that product property. 2 times x squared gives you 2x squared, so you can split it up like that. The square root of 2 doesn't simplify, but x squared is a perfect square. So when you take the square root of a perfect square, you get just a whole number. So this just turns into x. This guy doesn't simplify. It's just the square root of 2. So look what you found. I'll use a different color so maybe it shows up a little better. If your legs are x in a right triangle, then your hypotenuse is that same x times the square root of 2. That's what we just figured out on that multiple choice question. So the next time you see a right isosceles triangle, Maybe this is 5 and this is 5. How long would this be? 5 square root of 2. You don't need to do the work over and over and over again. We did it one time. The reason we use variables is so it works for every number. So if you put a 5 in here, it works. If you put a 27 in here, then this is 27 square root of 2. So that's what theorem 7.8 is. It tells you about 45, 45, 90 triangles. It's the 45, 45, 90 triangle theorem. It tells you that the hypotenuse is the square root of 2 times as long as each leg. So call your legs x, your hypotenuse is x times the square root of 2. So if you know these, you can find that. Also, if you had this, let's pretend this is 10 square roots of 2. How long are your legs? They're going to be 10. All you do is take that hypotenuse divided by the square root of 2, and then your radical 2's cancel. So next video, we're going to do some really easy examples that follow this.